Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, we're going to start looking at solving equations or differential equations numerically using ODE45 in MATLAB. So, okay, first thing is we're going to be doing this ODE solver, and there's all sorts of different solvers that we can use. We're going to use 45, which is the basic Runge-Kutta method. But the way you are going to set it up is that you need to name it so that t and y, we want an array to be filled with the solution. And then whatever your ODE solver is, your function, your initial value, if you've got a final value, your initial conditions. Now, if you don't specify the result, being to go to ty, the array, then what it's going to do is create a plot of the results, and that's probably not really the most useful form. I mean, it's helpful, but you want the values. Now, the one we're looking at today is the most common and usually our starting point, and that's ODE45. It's for non-stiff differential equations using the Runge-Kutta method. And most of the time you don't know whether your equation is stiff or not. Now, stiff, if you haven't run into that term before, usually is referring to functions, say, where for a part of the range of values for x, you get, maybe very small, and then it quickly changes scale to something where the y values are very much larger. And so you want to change your technique as you change the behavior of the function. But for things that are going to behave fairly similarly throughout the process, then a non-stiff system is going to be appropriate. And ODE45 is usually where we start. And if you don't like your answers, you try something else. Now what we want to do is start by looking at the solution to the equation dy dt equals 2t, subject to y of -1 equals 1. And we want to do this by setting up an anonymous function. So remember that an anonymous function, so dy dt equals at, and I want to name both the variable t and y, because remember, dy dt is like a variable, and so it's a function of y and t. And so I want to list both of those, and then that function is actually 2 times t. All right, so that's going to be my function. And so far so good. I've got a function. What I want to do is set it up so that I get ty is going to be the solution. Now my ODE solver in this case is ODE45. Again, that's the most common one. And I'm solving the function dy dt subject to the initial conditions that when t is equal to -1, y is equal to 1. And the initial condition in my array, which I want it to start at the first value, okay, is this. And so what it gives me is it gives me the list of all of the t values and all of the y values. Now, I can also come in and just simply take this and what it does is it creates a graph. If I didn't specify it was going to t and y, it creates the graph, which is actually very nice because that can confirm whether the behavior is what I expected to have. Okay, so this is the basic way that dy dt works. When you get a result that isn't as expected, then that's an opportunity for you to try one of the others that we'll be looking at in future lessons. Although in our next lesson, we're going to look at higher order differential equations. Thank you very much for your time.